Hello, I welcome you all. The problem reads that the 75 pound block is released from rest 5 feet above the plate. Determine the compression of each spring when the block momentarily comes to rest after striking the plate. Neglect the mass of the plate. The springs are initially unstretched. This problem is coming from the Engineering Mechanics and Dynamics 13th edition by R.C. Hibbeler. So we have the block like so. So it comes to drop here where we have these springs, right? What happens? Of course, these springs will get compressed, okay? But there is already some distance here, right? So as they get compressed, there'll be a point where they'll momentarily stop. As they come down like so, there'll be a point where they momentarily stop and then they start going up. So it is at this point where we want to find this compression, okay? And at this particular point, V is going to be equal to 0. Right, and all the forces that are acting in this particular system are conservative, and therefore we can use the principle of the conservation of mechanical energy. So let's go for it. So let's say these are the points that we are interested in. Right. So let's write this one, maybe move it further like so. So we have this one, and we have this one there. Okay. Right, there we go. Alright, let's call this S, and then let's call this H2, which is equal to 5 plus S. Okay, what else? So let's say our SA is equal to SC is equal to S, and our SB is equal to S minus 0.25 feet. Then our KA is equal to KC is equal to K. Right. So therefore, we have, let's call this point 1, this point 2. Then we have our V1 is equal to 0. So is our V2 equal to 0. So our kinetic energy, point 1 plus potential energy, point 1 is equal to kinetic energy at point 2 plus potential energy. So this is equal to half mv squared, and V we have due to gravitational, okay, this is WH, and VE, this is half KS squared. Alright, so let's write everything else. We have half mv1 squared plus half ks1 squared, okay, plus wh1, this is equal to half mv2 squared, okay, plus minus wh2 plus 2 of them which are similar, k s squared, right, and then plus half kb, then we have s minus 2.25 squared. Alright, so this is 0 because v1 is equal to 0, This is 0. Okay. S1 there is nothing. This is 0 because H1 is equal to 0. Okay, this is 0 because V2 is equal to 0. So this will remain with just a 0 is equal to minus W is a 75. Then this is falling through H2, which is 5 plus S. Okay, and plus this one, this just becomes 1,000 feet by S squared. Then half by 1.5, this just becomes a 750. And this is S squared, this squared, and minus 2.25 S, and then we close brackets. Okay, so therefore this just becomes minus 75 by 5. This becomes minus 375, then minus 75 S, then 1,000 squared, then 750 squared, and then plus 750 by 0.25 squared. This gives us a 46.875, then minus 750 by 2 by 0.25. So this just becomes a 375 S. Right, then finally this just becomes we have 1,000 plus that. This just becomes a 1750 S squared. Okay, S squared. That was 750 by 0.25. Alright, and then we have 75 minus 75, the minus 375. So this becomes minus 450 S, and then later on we have a minus 375 plus 46,875. So this just becomes minus 328.125, and this is equal to 0. Okay, this is equal to 0. Right, so now using the quadratic formula we have two solutions. So this just becomes a minus B, which is minus 450, plus and minus 450 squared minus 4 A by minus 328.125. Okay, there we go. And then we are dividing this. Of course, this is under the square root. This is under the square root. This is just a 2 by A. Okay, then we have S. We have S, I just want a positive S. We have S equal to that's 415 squared plus 4 by 750 by 328.125 square root of that, and then plus 415 divided by 2 by 1750. Alright, so this gives us a 0.5803. Okay, so SA is equal to SB is equal to S. not SB, SC is equal to S, and SB is equal to S minus 0.25. Okay, therefore SA equal to SC equal to S is equal to 0.5803 feet, and SB is just going to be equal to minus 0.25 is equal to 0.3303. Okay, 0.5803 minus 0.25. The units also the same. Okay, I think this is about it. We have found the compression of each spring when the block momentarily comes to rest after striking the plate. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.